All right. Welcome, welcome, welcome. We are going to be solving by factoring. So we're in your workbook here on page 8, starting with unit 7.4, question 133. In this video, I'm going to go through all of the odd problems. I would encourage you to pause the video, work ahead, then watch the video to see if you're getting the hang of things, right? You can always do the evens after the video as extra practice, but I think one great way to practice this would be to watch a few examples and then pause the video, try an example, then watch the video to see how well you did on it. All right, here we go. So we have an equation already factored, right? We know it's already factored because we've got these two different factors, these two different parentheses. And essentially what it's saying is this factor right here, let's make these two different colors here. The factor in purple times the factor in blue equals 0. If you're going to have two numbers being multiplied together and the result is 0, there's only one way that happens. Either the first thing is 0 or the second thing is 0. So in this case, either our factor m plus 9 equals 0 or our factor m minus 8 equals 0. One of them has to be 0, otherwise we can't multiply them together to get 0. So once we set that up, we say, okay, well, if m plus 9 equals 0, let me just do a little solving here by subtracting 9. One of my solutions is negative 9. And over here, if I add, one of my solutions is positive 8. So those are the two values that when plugged into this equation would make it equal to 0. They're also the two x-intercepts if I were to graph this, right? Think about a quadratic, what that would look like. Graphed, it'd be a parabola. And so those would be the two places it crosses the x-axis. So when we are already in factored form, it's pretty straightforward. I'm not going to do the two different colors anymore. But either this factor equals 0, right, 4z plus 3, or this factor has to equal 0, z minus 9. All right, well, the z minus 9 is pretty straightforward. So one of our x-intercepts, one of our solutions, our zeros, equals 9. And when 4z plus 3 equals 0, we're going to subtract 3 from both sides. Dividing by 4, the other solution we have is negative 3/4. 137. Again, if I'm moving too quickly at any point in time, that's the wonderful part of the video. Just pause it. All right, 6x minus 5 squared equals 0. Well, if we were to write this out, this would be 6x minus 5 times 6x minus 5. And so we just say, well, either the 6x minus 5 equals 0 or the 6x minus 5 equals 0. Here's the thing. We don't need to solve them both. They're the same answer. We call this a double root. When you get the same answer, it's the same answer twice. If you think back to algebra 2, it's a bounce. It bounces off the axis. All right, I mean, the vertex of the parabola is on the axis, right? Throwing a lot of information at you to really just say, okay, in this case, you actually only have the one solution. It's 5/6. Here we have some fractional ones. Doesn't change our process at all. Ooh, that looks like a 4. Let me change that. Y plus 3/2 equals 0, and y minus 1/4 equals 0. Some pretty straightforward solving here. Y equals a negative 3/2. And y equals positive 1/4. This would be a good time to try some of the evens on that first part of this, because when we get to 141, we're kind of stepping it up a level here. Now we're going to factor. Now we have to factor it and then solve the factors. We know that we have to take this extra step to solve the factors because the original equation is equal. It's equal to 0. Okay, so away we go. 1 times 56 is 56. I need two numbers that multiply to be 56, but combine then to be 15. It's both going to be positive, so I have v plus 7 and v plus 8. And then again, I need to take that extra step now because of the equal sign. So either v plus 7 equals 0 or v plus 8 equals 0. Subtracting 7, one of my solutions is negative 7. Subtracting 8, my other solution is negative 8. Okay, I didn't spend much time showing you the factoring on that one because I am confident we can factor that one just fine. Let's look at 143. It becomes a little bit more difficult to factor when we have this leading term of a 3 out front. So let's see how we would do that. All right, I'm tired of the blue color. We're going to switch. So 3 times negative 10 is negative 30. So now I'm going to look at the different options here for negative 30. So if I am going to factor negative 30, come up with two numbers that multiply to be negative 30. Because 30 is negative, I have to have one positive, one negative. This middle sign here of a negative tells me that my larger factor has to be negative. So for instance, like 1 and negative 30, 2 and negative 15, 3 and negative 10, 5 and negative 6. And of those, one of those options is going to combine to be a negative 1. That's 5 and negative 6. There's two ways to proceed from here. I'm going to show you both of them. So I'm going to start with the grouping. If that's not the way you normally do it, then hold off. And then I'll go to kind of our shortcut method. So grouping says 3y squared plus 5y. And you could do this in either order. You could have the minus 6 first, but I'll just write it in this order. Doesn't matter. And now we're going to group out of 3y squared and 5y. I can factor out a y. And out of 6y and 10, I can divide out a 2. So that's going to give me y times 3y plus 5 minus 2 times 3y. Remember when that middle sign here, this one right here is minus, then it changes this one back here. So that becomes plus 5. These match, which is what we're after. So one of my factors is that matching 3y plus 5. The other one comes from the outside here, y minus 2. Now because it started as an equal, I've got to set this up and solve that. So I'm actually going to come over here to the side. Let me scrunch this down a little bit. And I'm going to continue working over here. So 3y plus 5 and y minus 2. One of those has to equal 0. 3y plus 5 equals 0, or y minus 2 equals 0. This one's pretty straightforward. The y equals 2, but this one's less so. Subtract 5, so 3y equals negative 5. Divide by 3. Y is negative 5/3. And again, I'll reiterate, I would encourage you to be pausing the video, working ahead a little bit, then using the video to help you out. Okay. 145 here. All right, so in this one we don't have, it's not equal to 0. At least not yet. We can make it equal to 0. So we're going to have to add this 54 back to the other side. When you're solving and you have a squared variable and what we call a linear variable, so one that's not squared, you need them on the same side. Put them on the same side and then factor. Okay, so by moving the 54 back over, notice I'm not going to combine those. They're not like terms. I just keep them. So d squared minus 15d plus 54, and now it is equal to 0. So now I can factor. This looks a lot like the one we just did a couple problems ago. 1 times 54 is 54. So this is going to factor into d minus 7 and d minus 8. And the reason they're both minus this time is because that middle term is minus. And then we need to take this over here and solve it. So now either d minus 7 equals 0 or d minus 8 equals 0, which means our solutions are 7 and 8. Okay, and so now we've got another little bit of an oddball here. We have 36 equals 25n squared. There's no n. There's an n squared, but no n. You actually have a couple ways to go about this, so I'm going to show you two different options. The first way is to just divide by the 25. So now 36 over 25 equals n squared. And then take the square root of both sides. So n equals, which the nice thing when we have a square root of a fraction is you can do square root of the numerator and square root of the denominator. So then that is going to be 6 over 5. Now, because we took the square root in solving, we have to consider both the positive and the negative. So we actually have two solutions. They are the plus and the minus. Okay, here's another way to solve this. Let me just rewrite the original problem. We could move the 36 So then we have 0 equals 25n squared minus 36. And now what we see over here is a difference of perfect squares, right? Square root of 25 is 5, square root of 36 is 6. So this actually factors into 5n plus 6 and 5n minus 6. And it's equal to 0. So then we say, well, okay, maybe 5n plus 6 equals 0, or maybe it's the 5n minus 6 that equals 0. Subtracting 6 from both sides, 5n equals negative 6. Divide both sides by 5. One of your solutions is negative 6 over 5. Adding 6, 5n equals 6. Dividing by 5, your other solution is positive 6 over 5, which is what we got the other method as well. So your choice there. That method only works if you just have a squared variable, but no linear variable. Okay. Continuing on, we are going to keep working up till 163. Yeah. Okay, so a few more to go. All right, 149. We got to get these all together. The rule is we want a positive. So I'm going to add the 20w squared and add the 30 at the same time. And really it's about putting them in the correct order. So the squared one comes first. It's positive now. Then the non-squared or the linear one. Then the constant or just the number. Okay, so now it's equal to 0 because everything is on the left side. Here we have a GCF we should factor away. When we have an equal sign and we have a GCF, it's actually pretty neat. We can just get rid of it. So let me show you how that's going to work. We're going to divide away 5. We're going to divide it from both sides. So instead of actually like factoring it out and keeping it, we're just going to divide it away from both sides. Okay. So now I have 4w squared plus 11w plus 6 equals 0. Okay, I think I told you on a previous problem I was going to show you both the grouping and the non-grouping method, and I didn't. So this time I am going to show you the non-grouping way we go about this. Okay. So we're going to do 4 times 6 is 24. All right, so I need some options for 24. 1 and 24, and they're both positive. 2 and 12, 3 and 8, 4 and 6. And so we're going to use 3 and 8 because they combine to be 11. Our shortcut says start both of my factors with a 4, right? Because we're looking at this right over here. Yep. All right. So 4w plus 3 and 4w plus 8. And then we can cut this one down by 4. So my two actual factors are 4w plus 3 and w plus 2. I know we have to solve them. Let me slide these over a little bit. Switch colors here for dramatic effect. So now we have 4w plus 3 and w plus 2. Setting each of them equals to 0. All right. Subtracting 3 from both sides. 4w equals negative 3. Dividing by 4. One of our solutions is negative 3/4. Our other solution is negative 2. Oof, let me rewrite that. A lot going on in this problem. Okay, so I would encourage you to go ahead and try 151, and then we'll work through it here in just a second. I'm actually going to work through 150 with you as well because it's a different type of a problem. So, okay. Let's take a look at 150 first, right? So if you're not done working through one of the other problems, just go ahead and pause it. So when you have a squared and a linear term, we should get them all together. So I'm going to subtract the 11p. So now what I have is p squared minus 11p equals 0. What's interesting about this one, there's only 2 terms, not 3. They both have a p, so that actually tells me GCF. I just have to factor out what they have in common. So I'm going to factor p out of both of those. So then I'm left with p times p minus 11 equals 0. And now I just say, well, either p equals 0. So that's actually one of my solutions. That's an answer. Or p minus 11 equals 0, which in this case, adding 11, p equals 11, right? So there's my other solution. So we still have two answers, but this case 0 actually is one of our answers. Okay, 151. I'm going to get you started on 151 here. We got to get everything together because we have both a squared term and a linear term, so we got to move everybody together. We want to keep the 18 positive if possible. Although let me show you what would happen if you didn't. So I'm going to subtract 18k squared because we're going to make it positive anyways. So now I have a negative 18k squared plus 45k plus 27 equals 0. All right, so here I'm going to factor out or divide out a GCF, and I can actually divide out a negative 9 from everything. Notice I'm going to divide it from both sides. It actually then just kind of goes away, which is really nice. So now I have 2k squared. Oof, try that handwriting again. Minus 5k, right? Because I'm dividing 45 by negative 9. Minus 3 equals 0. And now we factor. 2 times negative 3 is negative 6. Looking for factors of negative 6, so I have to have one positive, one negative. The larger one matches the middle term, so the larger one's negative. 1 and negative 6, 2 and negative 3. We're going to use 1 and negative 6. Okay, so into my two parentheses, 2k plus 1 and 2k minus 6. And you could do this by grouping, of course, and you'll get the same spot. So 2k plus 1 and then k minus 3. Those are our two factors. And because we started with an equal sign, we got to set them equal to 0. So either 2k plus 1 equals 0 or k minus 3 equals 0. 2k equals negative 1, dividing by 2. K equals a negative 1/2. Adding the 3. K equals 3. And so there's our two solutions. All right. I'm not going to do 152. I'm going to do 153. So this is where it starts to get a little bit messy. 153, 55, 57. Those would get to be pretty tough. All right. So let's look here at 153. So first thing we actually have to do is multiply it out. So now that's 4j squared minus 32j when I distribute that 4j. Now I'm going to move the 63 over here. Right? I would certainly get one or two of these on my note card because I know there's a couple of them on the exam. They're pretty tough. So let's see, 4j squared minus 32j plus 63. All right. So now what we're doing here is looking for a GCF. So we're going to see if there's something I can divide out of all of them. There's unfortunately not. So we're going to have to do some factoring here. Okay, so 4 times 63 is 252. So now I'm looking for factors of 252 that are going to combine to be 32. So okay. And they're both going to be negative because they multiply to be a positive. All right, just doing a little division. All right, so 252 divided by 8, divided by 9. So, whoops, Just trying some things here. I've got 9 and 28, so that doesn't quite work. Hmm. 12 and 21. 14 and 18, and there they are. Remember we said they were both negative. Whew. It took some work to come up with those two factors. Okay, so then we're going to go into our two factors. Switch colors here just because I got a lot going on. So we have 4j minus 14 and 4j minus 18. Divide them both by 2. 2j minus 7 and 2j minus 9, and then set them equal to 0. Add 7, 2j equals 7, divide by 2. One of our solutions is 7 over 2, 7 halves. Adding 9, 2j equals 9, divide by 2. The other solution is 9 halves. Right, so there's our two solutions. All right, like I said, a lot going on here. There's a couple of these on the exam. For sure, one on the free response. So you're going to want to be prepared to go through all this. All right, 155. Starting to get messy here. In 155, I'm going to start by distributing. So multiplying these out. So let's see, that's 3h squared minus 12 equals 5h squared minus 5h minus 9h. All right, we'll combine those. 3h squared minus 12 equals 5h squared minus 14h. And then I'm going to move these over here. So I'm going to subtract the 3h squared, and I'm going to add the 12. So we have 2h squared minus 14h plus 12. And I'm immediately going to go ahead and get rid of a 2. So now I have h squared minus 7h plus 6. And now we're going to factor into 0 equals h minus 6 and h minus 1. And so our solutions are, sorry, let me write it out. Either h minus 6 equals 0 or h minus 1 equals 0. So adding 6, h equals 6, adding 1, h equals 1. Okay, all right. 157. Multiply. So now negative 84 equals s squared plus 19s. Add the 84. 0 equals s squared plus 19s plus 84. This one's pretty fair if you're on the test, right? Some of these get real messy. This one's pretty straightforward. So then 1 times 84. We need factors of 84 that are going to combine to be 19. And they're both going to be positive. So 12 and 7, right? So it's 84. So we're going to use 12 and 7. So s plus 12 and s plus 7. So then either s plus 12 equals 0 or s plus 7 equals 0. Subtracting 12, we get negative 12. Subtracting 7, negative 7. And there's our two solutions. Okay, that one's certainly fair game for the test. Okay. Yeah, 158's pretty tricky. Maybe we'll talk more about that one next class, but you certainly can try it. I'm not going to go through it right now. It's pretty intense. All right. So, let's take a look at 159. And I'm going to go through 159, 161, and we'll hold off on 163. So I'm just going to do these next two, and we'll save 158 and 163 to start next class. Okay, so you don't actually have to multiply these out, right? Kind of looks like we might, but you don't have to. You're just going to say, well, either this equals 0, this equals 0, or this equals 0, right? So we have 3 parentheses instead of 2, but same principle. If it equals 0, one of them has to be 0. For the one out front, divide by 8. So then 0 is one of our solutions. Subtracting 4, negative 4 is one of our solutions. Adding 1, 2y equals 1, divide by 2, y equals 1/2. So there's our 3 solutions there. So pretty straightforward one. Definitely going to be on the exam. 161 also there. So in 161, we're back to 2 parentheses, but something different happens here. We say 2r minus 5 equals 0, or r squared minus 6r plus 9 equals 0. Well, this one's pretty obvious. I'll just add 5, so 2r equals 5, divide by 2. So 5/2 is one of our solutions, right? But over here we have r squared minus 6r plus 9. We factor it. So this is actually going to factor into r minus 3 and r minus 3, right? Multiply to be positive 9, combined to be negative 6. So then r minus 3 equals 0. And I don't really have to do this one twice, but I could. Wouldn't hurt it. So 3, and of course 3 again. So really, if this were a multiple choice problem, you'd only see 2 solutions. It would show you 3 twice. Okay, we're going to hold off on 163 and 158, but you're welcome to try any of the other ones we haven't done yet. Reminder, there's also those factoring games on Schoology, the links for those as well to continue to practice factoring.